Hi, and welcome to another episode of Raw Green, a show produced by OBE, your sustainability consultancy specializing in life cycle assessment, research, and green tech. Check us out at oneobe.com or connect with us on socials. Links are ready for you in the description. Ciao! Hi everyone, and welcome back to Raw Green. Today's episode is a special one. Raw Green is getting an upgrade. I'm really excited to introduce my new co-host, Emma Mee from Green Angel Ventures.
Hey, Francesco.
You may remember... Hey, Emma. You may remember Emma from a past episode and how well we got along. So I asked her to join me behind the microphone full time. She's sharp, passionate about climate tech and sustainability, and brings energy and fresh insights from the world of green investing. Ciao, Emma. You're in.
Ciao, Francesco. You flatter me, but look, let's be honest, it's because we simply couldn't stop talking. We were never going to be able to contain what we were talking about into one single episode. So this is awesome. We get to do it again and again with fresh new meat that's thrown in to get stuck into some new technologies. And naturally, of course, with Green Angel Ventures, I'm sort of bringing with me an amazing portfolio of climate tech companies. And I know that we're both excited to get stuck into each one of those one at a time. We're not going to run out of good material anytime soon, are we?
Feel free to post on LinkedIn about regretting this. I can already picture it in classic LinkedIn language. I am delighted and thrilled to announce that, regrettably, I have joined Raw Green as a co-host.
It's too early for that, but let's talk in half an hour.
Francesco is a pain in the ass, but I would like to thank myself, the Vatican, the internet, Spotify, the transport department for the opportunity.
No, I'm really looking forward to get stuck in. I think, Francesco, I'm going to be here to sort of ask the stupid questions. I want to be able to pull you out of some rabbit holes that you get stuck into with the technology side of things, so that we can, cover more ground at times. But yeah, no, ultimately, I'm just really excited to see what we can uncover together on this.
Fantastic. Then let's start to uncover. Let's dive into the episode. So today we're joined by Christophe Williams, the founder and CEO of Naked Energy. So Christophe pioneered a hybrid photovoltaic thermal technology that delivers both clean power and usable heat from the same rooftop, from the same area. So he's here to walk us through the tech, the trials, and where they're headed next. So Christophe, ciao. Thank you for joining us and welcome to Raw Green. How are you?
Ciao, Francesco. Lovely to meet you, and nice to meet you too, Emma. I'm doing great, thanks. Great to be here.
So, Christophe, I think I get to ask you the first question. This is like rite of passage now. So, tell us, please, what was the aha moment that you had in your background? Because it doesn't align, does it, with technology initially? I believe you were in advertising to start with. So, what was that crucial moment that made you go, "This is it. I want to do Naked Energy. This is what I'm going to dedicate my life to from now on"?
That's a great question, and I asked myself that question repeatedly too. The aha moment for me was when I met two individuals who were inventor/engineers whilst I was still in the advertising world, and they were working in renewables and particularly solar heat, and they kind of showed me the potential and the challenge of decarbonizing heat. And it was like, wow, heat consumption in the world is actually 3 times more than electrical consumption. Everyone talks about power, it's for our lights and fridges and all the other things that we use electricity for. That's only 20% of the world's energy. And heat is 51%. That's hot water, space heating, process heat in industry, which is responsible for 40% of all global emissions. And only about 12% of that comes from renewable energy. So it's incredibly a big problem. And they opened my eyes to that challenge. And it was like, oh, wow, I really, really want to do something about this. And it was quite frightening, but also exciting in terms of the opportunity. And they were developing some technology, and I come from a more creative and design background, and came up with the concept of the hybrid technology in the vacuum tube, which I don't think any sane engineer would come up with. It's very, it's not your conventional bringing together of technologies, because you've got vacuum, you have fluid, you have electronics. So yeah, it was quite out there in terms of the origination of the idea, and then the journey started. Because for me, my original inspiration to get into sustainability and renewable energy actually goes back a couple of generations. It goes back to my grandfather, who was actually the chief scientist and ran the clean energy division. In fact, it was called alternative energy division of John Lang in the 1970s and 80s. So he was doing clean energy during the first oil crisis in 1973. So it's amazing. And when I was a little kid, he said to me, Christophe, one day fossil fuels will run out and we need to look for alternatives. And that was a light bulb moment, but I was just a little kid. I hadn't really fully comprehended the magnitude of what he was telling me. But he was a brilliant scientist, worked with Stephen Salter, Professor Salter, working on wave power, flywheel technology, which stored energy from one power station, shutting down to the other. Just a remarkable scientist. And my father is an aeronautical and mechanical engineer. I'm not an engineer, but my daughter's a scientist. She's a physicist. So I often say that the brain skipped a generation, or many generations. I went from my lineage to my daughter's. But I always had an itch to do something in renewable energy. And so when I met these two guys who were inventors and showed me the size of the problem, and I wanted to use my sort of more creative and design background to start Naked Energy. And that was the light bulb moment. I said, look, I'm going to abandon, which was a pretty established and successful career in advertising, where won quite a few awards, a Clio Award, got in the Guinness Book of Records, did remarkable, and what I think I'm very proud of, career, to go into the unknown of doing Naked Energy. And so that was the plunge. And I asked myself one simple question after we won an award with Shell, which was £40,000 cash prize, and we got £500,000 of investment from 3 business angels. And I was still doing my day job, and I thought, could I live with myself with not taking a chance and going and trying this technology out and this opportunity out? Yeah. And the answer was clean no. So I took the jump, and it's been a 10-year overnight success.
Well, with
it's been a long journey.
With that sort of lineage, I don't think you had much of a choice, Christophe. So welcome to the green side.
Exactly. So
look, let me ask you this. I'm glad that you talk about your let's say how this started, and there is one thing that it got my curiosity, which is the innovation in the renewables, and more importantly, the pace of innovation in renewables. I personally don't think that it is keeping pace with different other industries in terms of growth curves or innovation curve. Okay, and from your point, you brought to the market something that perhaps in a few minutes you can give us a little bit more details and technicalities on how it works. But my question is do you think it is technology, renewable energy technology, and solar especially technology advancing quickly enough relative to deployment? Especially, we're seeing now gigawatts scale project, but the tech is still that one. What do you think about this?
My personal view is that technology is mature. Billions of dollars have gone into solar to turn it into something that's become ubiquitous. It's a commodity effectively to buy a PV panel. And so I think that technology is incredibly mature. It's dropped down that learning curve and become incredibly cost effective. So there's not much, I don't think, kind of innovation that can happen within a silicon cell, because it's got to around 20% efficiency. There are some that are really high, like gallium arsenide, in terms of the efficiency is higher, but those are originally developed for space, for satellite technology. They're incredibly expensive. But the monocrystalline cell that generates photovoltaic energy is incredibly mature. And that goes also for other core sectors like wind. A lot of investment's gone into those technologies, and they've reached a certain maturity where I think the innovation now is more about how do we scale these solutions? How do we actually get innovation into business models, into how we finance them, how we adopt them, how we digitize them? Because we don't need moonshots, more moonshots. I firmly believe the technologies exist. It's about, right, how can we get the capital to it? How can we make interest rates for clean energy technologies become much lower compared to the counterfactual, and that will rapidly accelerate. With our technology, we haven't invented something completely new, like a new material. It's just taking mature technologies, but we put them together in a very clever way. And so that's something that's very different. And so, yeah, to answer your question, I think there's been huge innovation, huge investment over the last decade, particularly in solar and wind. And I think that, the solutions exist. It just needs now more impetus, more focus, more political investment, capital investment to scale these solutions so that we can accelerate the energy transition.
So give us a bit of a description then, Christophe, of what Naked Energy has actually come up with. What's the technology that we're looking at here?
Sure. So we've developed a solar technology called Virtue. That's the brand name for our solar collectors. We have two types, actually. We have one that is we're kind of well known for is our hybrid technology. It's called Virtue PVT. So that's photovoltaic and thermal energy. And it produces from one source of energy, the sun. We produce two forms of usable energy. That's hot water and electricity at the same time. So you're simultaneously producing two forms of energy from one bit of real estate. So on your roof or land, you're getting hot water up to about 70 degrees Celsius, which can be used for sanitary hot water in buildings. It can be used for preheating for industrial processes. So we typically focus on commercial and industrial applications. And so it's the uniqueness of our technology as well is it's in a vacuum tube. So it's photovoltaic technology with a very novel and efficient heat exchanger inside a vacuum tube, which is like a thermos flask. If when you put hot water or cold water inside a thermos flask, the vacuum keeps it hot or cold for many hours. It's the same thing with our technology. We trap the heat from the sun. It's like a greenhouse effect within the collector. And even if it's cold outside or it's windy, we transfer that heat to the building where it's needed. So we get better thermal efficiency.
And it's not just one, is it? I've seen like they're lined up, aren't they?
It's modular. That's
modular
right.
tubes, sort of as many as
That's
you want,
right.
sort of vertical
Yeah,
as
you
well
can
as.
see them. That's right. Yeah, so it's an individual tube, but we have banks of 5 that we collect together, and then they can be ganged up into any size. So the largest project we've done is just under 0.5 megawatt project on a rooftop on the British Library here in the UK.
Nice.
And that's actually the largest and the biggest solar heat project ever in the UK. We're actually starting construction of a project which is a megawatt of solar heat, which is our sister product, Virtue Hot, that produces just hot water, and that can go up to 120 degrees Celsius. And that product is similar geometry, but very efficient at producing thermal energy. And we're installing a megawatt of that at a project in Coventry. And that's starting construction, which is really exciting. So that's going to beat the British Library project by some margin. And so, yeah, the technology is really aimed at customers and applications that need heat all year round. So you remember I mentioned the heat problem, it's 3 times more than power. Well, applications like, for example, the manufacturing industry, they need hot water and heat in the summer for cleaning in place, sanitization, sterilization, things like that, in the bottling industry, food and beverage industry. The hospitality sector, where you've got hotels that need many cubic meters of hot water every day, healthcare industry, so hospitals, clinics, and then multi-dweller, so residential applications like care homes, things like that, and also university campuses. We've done quite a few of those sort of projects where there's constant hot water demand. So we generate heat where it's needed, and that's the kind of technology we've developed is very efficient. So at the collector, but also how we've designed it to go onto buildings is very compact. So it generates more kilowatt hours of usable energy on a commercial flat roof than any other solar technology on the planet, which means you save more energy, you save more carbon, you get a better ROI from a financial and a carbon perspective.
How much
And
better? That was one of my
from,
questions.
yeah,
You have that higher density per square meter, right?
that's right.
Which so that higher density, does that translates in a higher capex or better ROI, return on the investment? If you can give us some figures on this.
Yeah, absolutely. So typically it is more expensive than a PV because PV produces just electricity. And as I mentioned, it's a commodity. It's very low cost, being very mature. It's lower capex. However, with our technology, it's a slightly higher capex, but you're getting more technology on the roof. You're getting more kilowatt hours. So the paybacks are similar and
Hmm.
similar internal rates of return. But the key difference is the absolute ROI, because you're generating more energy for that fixed area of roof space, and
Yeah,
all the fixed costs of designing it, installing it,
yeah,
are recovered and amortized more quickly. And so you're getting a much greater ROI, which can be up to 100% greater ROI compared to a PV installation. And for customers that need hot water, that's really important. It's really good for them, right? Because normally their roof space is limited. That's one of the key constraining factors for a hotel, for a hospital, is how much roof space we've got. So
yeah.
if you've got that hot water demand, putting solar thermal or PVT down there really helps address directly that hot water demand they need. And if they have spare roof space, you can put PV down, you can put photovoltaic. It's not one or the other. They work really well
They're
together.
complementary. Yeah, yeah.
Yeah. And very importantly, solar thermal addresses scope 1 emissions. That's emissions that are being consumed or burnt on site, so typically from gas. Whereas a PV panel displaces grid emissions, which is scope 2 emissions. So we can really help customers on their journey decarbonize very effectively scope 1 emissions. And compared to a normal conventional PV panel, we can displace up to 4 times the carbon emissions for the same roof space, like for like. So that's quite a few of the sort of USPs of
And
the product.
and I've seen you done an APD too, which well done, by the way. It is very, very important, especially on let's say a green tech complex with a complex inventory of materials inside. So really well done on this. It is important that together with the energy part, both electricity and heat, and the decarbonization part, you have those numbers that your client can plug them into their reports. This is very, very important. You have to showcase both your energy performances, your decarbonization performance, your financial performances. Obviously, so it's triple output. I do have one more questions regarding the let's say the technology itself. You said that you generate higher returns, and one of, let's say, on the PV part, on solar PV, a very important component of it is the O&M side of it. What is it for the Virtue and the Naked Energy, the O&M consisting of?
The O&M
Because
being
obviously
operations and maintenance,
operation
right,
and
Francesco?
maintenance. Yeah. What is it? Is it more complex? Is it more expensive? You need a higher frequency of maintenance, of cleaning the collectors, otherwise you're going to lose efficiency. How does that work?
Yeah, great question. So, I mean, our technology itself is quite unique at the collector level, at the array. From the array to the building, the balance of plant, it's typically called, is quite standard. You know, their pipes, their cables, their pumps, it's inverters, storage tanks, whether it's batteries or thermal storage. So the balance of plant is the same type of O&M that you would have for a typical either solar thermal or PV integration. So there's no additional work that's needed if you're looking at separate thermal or PV. Compared to PV, there is more. There is more O&M because you do have mechanical integration.
The
You know,
exchanger, yeah.
yeah, you've got plumbing, for example,
Yeah.
and the plumbing, you need to size it correctly. So as part of the O&M, what's really critical and definitely part of our journey and learning is that you need to design the system right. So the right size, the right integration for it to work well and deliver the savings that the customer really needs. Compared to PV, there is more because you've got plumbing, so you need to check system pressure, flow rates, thermal storage, and that's another reason why at Naked Energy we developed our own digital platform called Clarity 247, so that the customer, the financier, and us can get real clarity on how the system's performing. So all those key vital statistics that I mentioned from a system operation, and it can send alerts. It can even predict if there's going to be an issue, and we've got aspirations for it to get smarter. So the more seasons it goes through, looking at climate data, looking at usage patterns, it can actually
Smart.
change certain set points and go, actually, I'm going to generate more kilowatt hours today because tomorrow's going to be cloudy, so I'm going to fill the storage tank. That's going to match the usage profile of the customer. So typically, there's a visual inspection. You can look at the sort of system pressures, and if it's installed, designed correctly, these systems last well over 20, 25 years and shouldn't need that much maintenance. But they do need, to be maintained in terms of making sure they don't go to overpressure, over temperature, and things like that. So if they're maintained properly, they last longer. But the O&M is more involved than PV. However, you are getting, as I mentioned before, you're getting more energy, you're getting more kilowatt hours, and you're addressing a real problem, which is that heat decarbonization.
Yeah.
So
Which
yeah,
has a very high intensity per thermal kilowatt hour. So in the UK, so it is a very good. You mentioned the British Library project
yes.
and this new very big one. Can you share some others where you saw the performance of the Virtue like skyrocketing? They were extraordinary.
I think with solar technology, what works well is, like most things, if they get really hot, efficiencies drop. And one of the unique things about our PVT technology is that we can take the heat away from the PV cells. So if you know a PV panel, you look at a normal PV panel, most viewers or listeners, if I say the word solar energy, they'll think of a PV panel. Inside those PV panels, you see silicon cells. And those silicon cells are measured at their peak power rating when they're at 25 degrees C and they've got perfect sunshine on them. That's the rating. As they get hot, they lose efficiency, about half a degree of efficiency for every degree above 25 degrees Celsius. And so, on a sunny day on a roof, they will get hot. They will get to, they can in certain climates get to 100 degrees Celsius, really hot because they're dark surfaces and they absorb the heat. So the electrical performance is sort of diminished. And particularly in sort of Southern Europe. Uniquely with our technology, we take the heat that comes in from the sun that hits those cells, because it's bonded to our heat exchanger, our patented heat exchanger, we take that heat away and we use it as hot water. So it's like waste heat. We use it as hot water that then can be used in the building. And so the combined efficiency of the collector at peak can get up to 75, 76% of converting the sun's energy into energy in that building, as opposed to, say, 18 to 20% at a collector level from a PV panel, and separately, say, 60% from a thermal panel. So we've seen incidences where we're getting that kind of combined heat and power output, and also the silicon cells not losing their efficiency because we're maintaining them at a optimal temperature that doesn't get to an elevated temperature. And the
You can
longest
cook on
project we've
it.
ever had running in the market is in Wales, the Active Office, it'll be 7 years this December. It's a really nice project because we've actually put 40 of those hybrid tubes on the south-facing facade of the building. And so what's really nice is in the winter we're getting really good output from because the typical bell curve, you need most of the heat in the shoulder seasons in the winter. So it's like taking your roof but putting it sort of south facing, and the tubes are facing south. But it's really nice in terms of seeing the performance output of the cells, because typically you have a degradation, each season, each time these cells are getting hot and being used and sort of stretched and they crack, with all this thermal expansion. We've got them inside a hermetically sealed vacuum, so they're protected from the environment and they're being super cooled by this heat exchanger. So we see that the PV output is very consistent. So we're seeing these sort of, this data coming back, which is really nice. So those are examples of where we can see really nice performance and output from the hybrid system.
I love technology where you think, why haven't we done this before? It's so obvious that that a combined system like that is just the smart evolution of where solar and things are going. But surely it can't have been that easy the whole time, Christophe. This wouldn't have been a linear path of technology development, right? Where did it fuck up? Where did you? What are some of the lovely anecdotes that you have of these things, combusting?
You want the fuck ups? Okay,
we do. The worse, the better.
Well, there was one that really sticks out. I mean, it's quite funny because it's really interesting because as you described my background, and this has been such a steep learning curve, and it's been exciting and incredibly rewarding, and I've worked with brilliant PhDs and scientists and amazing engineers and entrepreneurs. But I guess speed and getting things moving quickly, you have to be patient, and the energy transition is a hardware problem fundamentally, as well as software, right? We can't just solve climate change with software alone. So we need hardware solutions, and hardware is hard, right? It is harder because you've not only got to have something that's unique, it's got patents, and it's like easy to build, and it's lower cost, and it's better and lower cost and looks sexier than everything else. That's really hard to achieve. I think we've done that, but anyway. So I was really pushing the team, the engineering team, to independently test our product. Because we've developed our own lab, we've got our own solar simulator, so we have like an artificial sun. It looks like a giant tanning studio inside our lab. All these lights come on, and we have our collectors underneath. We've instrumented it very carefully so we can see how much solar energy is coming in, how much power we generate, how much heat we generate. So the engineers have developed this amazing test rig, and we got help from PA Consulting to design it and develop it. But we were getting unbelievable data out, and hence the word unbelievable. Note that word. Efficiency is coming out. It was like, wow, this is just so efficient, this technology. And we're about to do a capital raise, and we're looking to raise some money. And I was pushing the engineering team, and particularly my CTO, Adrian. I was saying, look, we need to go to Germany, to TÜV in Germany, and TÜV Rhineland. Nearly everything electronic you've got, even your phones, goes through TÜV. And their strap line is precisely right. That's a bold statement, right? But they are the grand masters.
They really are. They really are. TÜV is the best for these kind of things. Yes.
We always knew that we'd want to get our technology certified with TÜV in Germany. You can go to other test houses, and it'll cost less and be maybe less difficult. But we deliberately chose, look, we're a premium product, we're high quality, we want the stamp of approval from TÜV. So I was pushing Adrian to say, look, we need to get on a plane. We've got this great data. We're about to do this capital raise. I want independent data from Germany saying how good this is. And he was like, no, I'm not so sure. I think we need to do some more tests, and maybe, we need to recalibrate this. And I was like, no. We're getting on a plane, and we're going, and we'll send the product over, and we're going to fix it all up. So begrudgingly, Adrian went with me to Germany. We spent a few days over there. We set the test rig up, and we got all the local engineers in Germany ready. And the tests happen. We're in this lab, and it's this space. It's a bit like NASA. They've got this giant set of lights that are all calibrated, and they all come down, and little tubes there being sort of, it's like your baby. It's going to be tested. And the data wasn't so good. It was like, oh my God. And I said, guys, your meters must be wrong. Can you check your calibration? Can you and Adrian was just going, I told you we should have waited. And I was like, it was a good 20% down from where I thought we were, right? Where we were. And that 20% was painful. It was like, whoa, okay, what do we do? And I remember just sort of crying into my beer that night with an Adrian and said, "Look, this is bad news, good news." And I'm kind of going, "What do you mean bad news, good news?" It's like, well, we know where we are now. We know what we need to engineer. We know our base case, and we know what we need to improve. So yeah, that was a kind of horrendous fuck up in terms of like me pushing the team, really going against their will or their recommendation to be a little bit petulant and say, right, we need this. And it was a wake up call. But in the end, looking back, it was like a failure that in a way refocused our minds, and we had to go away and do more engineering and make the product better. And we have. So that was something I remember quite vividly.
Perhaps it was a good step. Yeah.
Yeah.
Yeah. In hindsight, I think so.
So you've gone from, startup, scrappy, builds it in the back of the shed kind of scenario, and it's been just over a year now that you've had a deal with E.ON. Is that right? They've invested a lot of money into you. How's that going? I'm really fascinated by the culture shock that startups face when they start working with big companies. How's that working out for you at the moment?
So you're right. Yeah, it's a quite a pivotal moment for the business. We've gone through quite a few investment rounds from sort of friends and family to like seed and then A round. we call this our B round because hopefully this is our last equity raise to get to break even. Right, we're still a loss making business, right? Because we've got to scale our business and get to a point where we're profitable, and we've got now a clear sight to that, which is really good. Because at the end of the day, I started the company and we are driving this business because we need to get big. We have to go at a scale that unless Virtue is on millions of buildings and we can say we're actually decarbonizing at least 1% of global heat demand, for me, what's the point? There's no point, right? No, so we have to have
a big target, Christophe.
It
is a big target. Yeah.
It is a big target. It's it's our sort of big, hairy, audacious goal. It's our BHAG. It's like if you don't set a big North Star, then you're tinkering at the edges. Is kind of how I sort of phrase it. So yeah, everybody at Naked Energy is like massively mission aligned. They really are there because we need to scale it, and so to do that, you need really big partners. You need big investors, big partners to be able to get you to that scale. And so we've been on the journey, and at the Series B, we set out to really try and identify and find a strategic investor that is aligned in terms of, they understand the heat problem. And when we met with E.ON, the executives at E.ON, their top 100 executives meet in Munich every year, and they go, right, what are our 10 biggest challenges and problems and risks to the business? And number one was heat decarbonization, right? And that tick is a massive strategic fit with us. It's like, yeah, that's what we're trying to address. And then it's like, okay, well, how are we going to get our technology to scale? What's the route to market? And the really good fit with E.ON is that they themselves are in 16 countries, and they have 19 terawatt hours of energy generating assets between steam and power. In fact, it's 11 terawatt hours of power. So they've got their own assets, which they control and monitor and need to decarbonize, but also they have commercial and industrial clients in many markets that need sustainable and affordable energy solutions. So they're a fantastic route to market. And on top of that, E.ON also, their business model is really to own the assets and sell the energy to those end customers. We call it heat as a service, so that there's the OPEX model whereby the customer doesn't need to pay a single penny on day one for the solution, because that's one of the biggest barriers to growth for the energy transition is the upfront cost of capital. So with E.ON, we have an offer whereby the customer simply signs up to a heat price, which matches or is less than what they're currently paying for fossil gas, but they sign up to that for about 10 to 15 years. And so it's zero carbon, it doesn't increase their OPEX, and they're saving money and carbon from day one. So that's a model with E.ON and an offer that we're doing. So that's the case and the strategic fit with E.ON. And you asked the question, how's it going?
That's the impetus
Yeah.
is clear, but the day-to-day is where it can really thrive or not.
Yeah, you're absolutely right. I mean, it's sort of David and Goliath, and but we're not kind of enemies, and that's kind of the key thing, right? Because startups, scale-ups need big partners, but there is a very different pace. There's a different kind of process. We're small, agile, hungry, annoying. Big corporates are like,
Quick.
very glacial, and big corporates, take time, and there's a lot of deliberation. And so, but the one thing that I would say about E.ON is, when I first pitched to E.ON, it was in Silicon Valley, and it was with one of their global board members. So they've only got 5 board members, and they got it. They really liked it. And so you've got the sort of top-down support, which is really critical from a big. Yeah, you need the executive to get it and understand it top-down, but that's not enough. What you really need, because then what you have to do is you've got to convince the operating side, the core business side of the energy, the big corporate, because they've got their ways, they've got their technologies, their processes, which, for them, E.ON are $120 billion business. And then we're coming along with a new innovative solution and suggestions. And so you've got to convince them. And that's the process that we're through, and we're going through and gone through. And there's always barriers. But the good news is that we have a clear sight now in terms of the size of the projects. And we have our first contract with E.ON, this project I mentioned in the Netherlands, in the Midlands. It's a 1 megawatt rooftop project. E.ON are the principal contractors. I can't talk about the customer yet because it's quite high profile and not public, but it will be public soon. And then with E.ON, we're now looking at their own assets, and we're into multiple megawatt scale type projects, which is a game changer for us. We're not just selling, say, 50 tubes to a customer. These are tens of thousands of tubes per project, per customer. And so we're getting into the sort of moving from rooftop to hopefully sort of ground mount and large scale projects. And so, the pipeline has gotten really big. E.ON are bringing us customers, which is excellent. We've refined the business model and the operating model. It's going well, and things always go quicker. I'm always going to say that.
That's good.
But it's going well.
That's good. Let me ask you, Christophe, you briefly mentioned heat as a service as something that Naked Energy is offering. I am a huge fan of energy as a service in general, whether it is from the producing part or whether it is from the energy efficiency part. There is that basically hammering of that initial cost per year for clients that makes totally sense. And from a client perspective, if I have you on board with me for 15, 20 years, I'm feeling really, really, really more comfortable in doing the switch. Okay. How do you see it going? How is it going with specific regard of Naked Energy, your offering of heat as a service? Because it is something that it exists from quite some time, over a decade, as a commercial proposition. But it hasn't been as successful as I think it should be. What do you think on this?
Yeah, you're right. I mean, from the power side, PPAs for wind and PV, they've existed for a long time, right? And that's been a huge stimulus for that market. Heat as a service has existed as well. Maybe it hasn't got the same uptake yet. I think the challenge, and probably that's the underpinning, is that heat is tougher, right? Heat for getting the gas data, is that for your heating, is that for your hot water? So understanding your heat consumption and then the heat price, because customers can either pay a fixed lease for the equipment, so a fixed fee per quarter, per annum for the equipment. They could lease the equipment, or they can they can buy like a heat price and sign up to that, and that's a fixed price, which is really good because, as you say, it takes away the risk, because the asset is owned by that provider and they just pay a price for the heat they consume. So it's de-risked. And then we've got all the monitoring data to show exactly how much has been produced and how much can be billed. And so I think heat as a service or heat purchase agreements have huge potential. They haven't really taken off yet. And I think it potentially is a combination of having the right funding partner, the right sort of cost of capital. Because this is something I think that, I touched on it a little bit at our intro, is something that it can be an absolute litmus paper for the energy transition, is getting the cost of capital down for projects that have a bigger decarbonization
potential,
and are solving a big problem, which is heat decarbonization. So you've got things like the National Wealth Fund here in the UK, GB Energy are being established. In Europe, as part of the Clean Industrial Act, you've got the Decarbonization Bank. That
you still need finance institution, though, Christophe. You need to have the big banks to operate on a much higher speed and scale on making clean techs bankable. You need to have that bankability. It's not just in the energy. I'm thinking about a number of other techs. Now, when you were talking, I was thinking about wind-assisted propulsion technologies that you can reduce 5, 10, 15% of your gas costs and emission costs. There's a big amount of money involved, huge amount of money involved from the shipping industry. So, and then there is your tax, and then you have lighting, and then you have, different kind of transportations methodology. So it is limited, but you need that. You talk about the pivotal part, the bankability of a technology. You got that piece of paper, you can be more creative financially and in your commercial proposition.
Yeah, and I think typically that's where it's really challenging for clean tech, right? Because you're perceived as higher risk, so the WACC, the weighted average cost of capital for your technology is higher, and so that reduces the ROI of the projects, makes them less sort of fundable, and makes the whole thing more challenging. Whereas investing in fossil fuels is just so low risk, right? You can get capital very cost effectively, single digits, easy. But for clean tech, it's much harder. So I think that's where, and I mentioned like these national wealth funds, the clean decarbonization bank. If they could just sit there and have their balance sheet sitting behind these projects as a guarantor, right? Then the private investors go, well, hang on, okay, so there's an off-taker, there's a guarantor on the ROI bankability of these projects. So actually, I can lend at 4% instead of 10%, right? Because it's de-risked. Then if the project is designed, implemented, maintained properly, they'll never have a call on their balance sheet. So then suddenly you've just managed to make all these clean infrastructure projects more bankable without having to spend a penny. So for me, it's financial engineering. I'm not a finance expert at all, but it's obvious. You've got to make it more economically attractive to invest in some of these first of kind clean tech projects where they're perceived higher risk, to get them to the point where then they can be rinse and repeat, and they can scale their solutions.
Bam, 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 bam. And you deploy projects on a much larger scale. I've been only once through the bankability of a new tech, of a clean tech. And that was like 15 years ago on pyrogasification technology for biomasses. It was a pain in the ass. It was one of the most excruciating and exhausting thing someone can do. And it is also a very big burden, but it is something that it is worth, because you break down that barrier and you enhance your also credibility and value proposition to the final users, to the final clients, that it is worth, absolutely worth taking the risk. Look, I got one more question, and then I think we're gonna do the Emma's quick fire towards the episode. Don't look at me like that.
It's horrible.
You haven't warned me about that.
You know, like the Emma's quick fire.
I'll do my best.
Now, what is the future? I wanted to ask you about the future. What markets or applications you're most excited to expand into? If you're gonna say America, I'm gonna say I have very big balls because the situation down there it is not the best. But curious to know what is your future?
Yeah, thank you. Yeah, I get my crystal ball out, but no, I mean we're a British company, so we're headquartered here in the UK, and we're doing projects here in the UK. And although it's not the sunniest market in the world, we want to keep doing big projects. And in fact, I can announce it because it was announced by them, and it's being commissioned today. Actually, we're commissioning a project with the All England Club in Wimbledon. So it's next to number one court.
Nice.
Yeah, next to number one court on the Orangi building. We're providing zero carbon hot water for the players when they shower and they go to the training area and go out to the pitches. And I'm still pinching myself. I was on the roof last week. I just can't believe it's on, Wimbledon All England Club, and I'm a bit of a tennis nut, and I live near Wimbledon as well. So it's incredible.
Congratulations.
So that's
Yeah.
going to really put solar thermal, I hope, give it some profile and raise awareness, because I call solar thermal the Cinderella of solar. It's like it never gets any discussion. She's always in the basement. I think solar thermal is a beautiful technology. For me, it's the purest form of renewable energy. You stand on a cold winter's day in front of the sun, you feel the warmth, right? That's all a solar collector does. Solar thermal collects that warmth, and it's very benign. It puts it into water, and you use that in the building for your showers, for your heating, whatever you need. It's a beautiful technology. And so we want to get Cinderella out of the basement to the ball and get more headlines and get people, financiers, policymakers, customers talking about solar heat rather than just solar PV. Because PV in general, we're buying it in Europe. It's a $6 billion euro import of PV panels. For solar thermal, it's actually $500 million export. We actually manufacture here in Europe and export solar thermal. Anyway, the future. What's happening? So we're UK based, want to do really great projects here, help decarbonize businesses and communities affordably in the UK. We are hiring, and we've just got our first hires in Iberia. So that's Spain, Portugal, which is really exciting. And we have partners in the Netherlands, and also we're hiring and doing projects in Germany. We have contracts with Hilton hotels, and we're doing our first project as we speak. We're commissioning a project there, so which is really exciting. And so those are our core markets. And yes, we are in the US. we have partners called ELM
Ta-ta-ta-ta. Yeah.
in the US. They're a microgrids business. They're in 22 states in the US. We've been working with them for the last couple of years. Yeah, it's certainly a state of flux in the US.
It's a roller
We
coaster. Yeah.
Yeah, we've done a few projects. We've done a university campus, a couple of ranches, off-grid ranches, and we have a nice pipeline with some big hotel chains and some universities for their campuses, and a couple of manufacturing groups, which are at the very late stage, but they've just been put, on semi-hold because of the sort of, is the ITC going to be there? What's happening at federal level? So yeah, there's a lot of turmoil happening in the US.
Yeah.
I still believe, and this is a really important point, which I haven't mentioned yet, as a technology, solar thermal, not only is it beautiful, but it's kind of grid edge. So solar thermal by default is a storage technology, because every system you put in has a hot water tank. And that can be anything between a 500-liter tank to a 1,000,000 cubic meter tank. It's, like the huge storage, like pits or in aquifers or in boreholes. And so it's grid edge. Every bit of energy that you generate on a building or on land by solar thermal, you're not injecting it back into the grid. It's grid independent. And so if you're generating heat for hot water, for all these processes I mentioned, that's less power you need from the grid to generate that energy. And you look what happened in Portugal and Spain recently.
Yeah.
We still don't know really what happened to the grid, but power grids are struggling. They're not used to all this renewable energy. It's something that we've built up over the last 100 years, and we're trying to decarbonize that energy infrastructure in the next 10 years, we will get there. But all this renewable power is creating challenges. So solar thermal, we don't do that. We're complementary. We generate heat where it's needed, and we're taking a load off the power grid that you'd have to have for heat pumps or electric boilers. So it's very complementary. And so the reason why I said that, because in the US, even though there's turmoil, there's still really good resilience arguments for actually putting this infrastructure on buildings to actually help with the grid and complement the grid. So at the moment, there's a couple of bills going through the House, or the houses in the US in terms of the ITC. I think the residential sector might get impacted. The commercial industrial sector, I think, will be okay, but there might be some sort of sunsetting clauses on them. But that might be a stimulus. All these businesses might go, hang on, let's get going because, whilst the ITC is around. But as a scale up and as a sort of, mission focused business, there's always this macro stuff that happens all the time. And when I started the company, no one was talking about really clean energy. No one's really talking about heat. Heat still is like the big elephant in the room, heat decarbonization. But the penny's starting to drop now. It's starting to get more attention and more focus. So you just have to stay resolute and focused and go, right, we just got to keep doing building by building, project by project, partner by partner, and just keep pushing ahead in our markets.
I love that, Christophe. So whether you live in the UK, Europe, or in the States, we're just telling people to just look up, right? Look up and see the naked. You can have that. Your advertising background is, is going to enjoy that one. But we really look forward to seeing some of these tubes shining brightly. Your Cinderella on the roof, particularly at Wimbledon. I think that would be great. There will be good TV coverage, I should imagine, of that with the drones as well.
I hope so. And thank you for that.
Lovely. Right. Are you ready to do a quick fire round?
Yes. Shoot. Fire.
So what is the one solar or clean tech innovation you're most excited about right now, excluding naked energy, obviously?
Yeah. I think one of the key areas for me is long duration storage. So we need to be able to take energy and store it for a long time. And one of the areas I think is really innovative is thermal storage, like thermal batteries. There's a project in Finland where there's a 90 gigawatt hour heat storage. They're taking like a whole town underneath and they're storing water from the summer. You can take heat and solar energy in the summer and you can store it and use it in the winter. And for me, it's quite low tech, but it's actually really cool because it means that we can solve the winter load problem. You need heat and hot water in the winter. And don't burn stuff. Just use that big ball in the sky and store it in water, which is a great medium. So I think innovation around long duration heat storage is really exciting.
So my follow-up question is, if you could snap your fingers and solve one challenge in clean energy overnight, what would it be?
Heat decarbonization.
And tell us a little bit about where you see naked energy in, say, the next 20 years. What's your dystopian future that you're aiming for here in terms of your moonshot vision?
I would love to see Virtue with Clarity, all the monitoring platforms integrated with lots of other mature technology that already exist today, whether they're controllers, batteries, inverters, all integrated in a smart digital way on millions of buildings around the world, generating clean heat and power. And if Naked Energy owns those assets and sells the energy, even better. I would love that because that'd be quite nice. So that's the view, that's the vision, and hopefully something we can achieve in a couple of decades' time. Because if we can achieve a clean energy infrastructure where people are consuming clean energy, they're doing it in a smarter, more affordable way. There's going to be less geopolitical conflicts. There's going to be less wars over who's got oil and who's got this resource. It's going to be a much, much nicer world to live in, we hope.
Nice. Those were good answers, Emma. Huh?
Yeah.
we like that vision, and I love that you see the virtue as something that complements with our technology. For example, heat pumps. It is something that could work well together with the virtue and other thermal technology we had on the podcast, Caldera, which develops thermal storage, and that's perfect. It is in your range of temperature as well. They're below the 200 degrees. So in commercial opportunities, for commercial operations, production is perfect. That's what
Exactly.
you want. And that's the numbers that you mentioned at the beginning, that 40% of heat, of emissions, that can be decarbonized. It's a huge number. It's a huge number. Look, Christophe, I wanted to thank you for being on Raw Green. This was a fantastic conversation. I had lots of fun, and my co-host, I think too, had quite a lot of fun. I do look forward to catch up with you again. Maybe we can talk also a little bit more next time about the production part. I'm very curious to know about that. But thank you.
Thank you
very
for
much
sitting in our
for
hot
being here.
seats, Christophe.
Absolute pleasure. It's lovely to meet you both, and thanks for hosting so well. I really enjoyed the conversation. Thank you.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At OBE, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!